Consider this degree sequence 5533222. Let us see if we can draw a graph for this sequence. Please note, we had left the earlier video with a question. I had given a sequence there and told you to draw a graph. If you draw a graph for this sequence, then answering that will become obvious. Let us attempt drawing a graph for this sequence 5533222. How many vertices are there? There are 7 vertices. So let me name them A, B, C, D, E and F. So these are the 7 vertices. Now I'll write the graph here separately and I'll write the sequence here. So let me write it like this: 5A, 5B, 3C, 3D, 2E, 2F and 2G. Yes. Now this is my sequence. Let me name it as S1. Now what I'm going to do is observe the first vertex degree. That is, observe the degree of the vertex A. It is 5. What does it mean? It means that A is connected to 5 other vertices. Right? Without loss of generality, what I'm going to draw here is I'll draw 5 edges emanating from A. From A, I'm going to draw 5 edges. So let me draw edges to B, C, D and E. Right? Do you see the graph? See, I'm constructing the graph this side, so you must be able to visualize the graph as well as write the sequence here. So now, do you see that? Okay, I had drawn 4 edges, so this is another one. This is F. From A to F, this is the last edge. So we have 5 edges coming from A to B, C, D, E, F respectively. Now, what has happened to the sequence? Let me modify it. I have finished drawing 5 edges of this vertex A. So A, right now in the sequence, instead of keeping it empty, let me put a star here. So what does this mean? The star means that I'm done with A. Here, I can go to the next vertex B. So star, comma. Now observe the graph here. B has got 1 edge already. Right? So from 5, the degree reduces to 4 now. And the same with C. Earlier, the degree of C is 3, 1 we have completed, so now it becomes 2. D, earlier the degree was 3, now it has become 2. So what is it? It is star, comma 4B, comma 2C, comma 2D. Now, what is the case with E, E, F and G? The degree of E and F are 2 each, but 1 is already done here, and therefore the degree, the modified degree becomes 1 for both of them. G, we see that A is not connected to G. G remains as such. Is it clear? I feel with the next step, things will become more clear to you. So G remains as it is. The degree of G remains as it is. So let me complete this. It is 1E, 1F and 2G. Now, let me name this modified sequence as S2. So this is S2, this is S1. Now, what am I going to do next is, do you see that we have 4, 2, 2, 1, 1, 2 here. So let me write that in an ordered way. What I'll write is, I'll just make some arrangement here as star, 4B, 2C, 2D. So it has remained unchanged. Now 1E, 1F and 2G, I will write it as 2G, 1E, 1F. I've just replaced a few vertices. Now let me call this degree sequence as S2 dash. You see there is no difference between S2 and S2 dash. The only change I've made is I've replaced or rearranged the degrees here and there of E, F and G. That's it. So I'm done with S2 dash. Now, we were done with the vertex A. Let me now go to the vertex B. The actual degree of vertex B is 5, but it has already got 1 from A. So what does it become? So from B, I'll give 1 to C, 1 to D, and then observe. I'm not going to go to E, rather I'll give 1 from B to G. Did you observe that? And then we have 1 more remaining. I'll give that to E now. So 1, 2, 3, 4, 5. Yes. So B also has the degree 5. So A is done, B is done, and the other degrees have got modified. So now let me write the sequence. Star as usual for A, and for B again I'm going to write the star because 5 is done here. Now C becomes 1 reduced, so it is 1C. D becomes 1 reduced, so it is 1D. G again becomes 1 reduced, so it is 1G. And I've given 1 to E2 from B there. There is 1 edge from B to E, and hence this becomes 0E. Right? And F remains as it is. F is unchanged. Did you observe that? Now, let me name the sequence as S3. Moving ahead, what I did as S2 dash, I'm going to repeat that procedure and name it as S3 dash. So what does it mean? I'm going to rearrange the sequence S3 to form a sequence S3 dash. So what is S3 dash? Star star, 1C, 1D, 1G, 1F and 0E. So what do you observe from this sequence S3 dash? You see that we are done with A, we are done with B. Now let me go on to the vertex C. So C requires just 1 more degree. So what am I going to do? I'm going to give C. Just observe, C also needs 1 more, D also needs 1 more. So I'm going to connect C and D. Did you observe that I'm done with C and I'm done with D as well? Now, this is the sequence S4. I'm not going to give any other edge from C to E, F or G because I'm done. I just have to do 1 more edge. So what is the sequence S4? Star star, and for C again a star. D is 0 because we have satisfied the condition for D now. So let me put a star for D also. 1G remains as it is, 1F remains as it is, and 0E remains as it is. Now this is the sequence S4. Now, and we don't need a step called S4 dash. We don't need such a sequence. Why? Because it is already arranged. We have 1G, 1F and 0E. So it is arranged. Now, you must be thinking that the next step will be trivial because you observe here G requires 1 more degree, F requires 1 more degree. Yes. So what are we going to do? We are going to connect G and F. We are done because now what is the sequence S5? S5 is star star, star star. Yes, G also has a star because we are done with G. We are done with F also, star. 0E, which means E does not need any more edges, rather any more, its degree criteria is satisfied. Yes, this is our final graph. Let us check if we have done it correctly. A has got degree 5, B has got degree 5, C has got degree 3, D has got 3, E2, F2 and G2. Yes, and we are done. Now, can you do the same thing for the question which we left in the previous video? 5, 5, 5, 5, 2, 2, 2. Can you do this and obtain a graph for this sequence?